Hi girls, in this video I am going to tell about the concept of linked list in C. So what is linked list in C? Or linked list is a linear data structure. Unlike arrays, linked list elements are not stored at a contiguous location. The elements are linked using pointers. Okay. So normally a list refers to a set of items organized sequentially. That is called a list. An array is example of list. In an array, the sequential organization is provided implicitly by its index. You people know that the index are used to access the integer elements from the array. One major problem with arrays is that the size of an array must be defined at the beginning. This may be a difficult task in many real-life applications to give the size of the array previously. A completely different way to represent the list is to make each item in the list part of a structure that also contains a link to the structure containing the next item. As shown in the figure is given below. This type of list is called the linked list because it is a list whose order is given by links from one item to the next. Here this is the structure 1, structure 2 and structure 3. There is a link between the three structures here. Each structure of the list is called the node and consists of two fields. The first one field containing the item, the second field containing a pointer to the next item. That means there is a link from one node to the next node. So each structure of the list is called a node and consists of two fields, one containing the item and the other containing the address of the next item. That is a pointer to the next item in the list. A linked list is therefore a collection of structures ordered not by their physical placement in memory like array, but by logical links that are stored as a part of the data in structure itself. The link is in the form of a pointer to another structure of the same type. You have also keep it in your mind that the link is in the form of a pointer to another structure of the same type. Such structure is represented as follows. Here this is the struct keyword. This is the tag name. Within the structure, the member of the structure is item. This one is the struct node star next. This is the pointer to the next node. The first member is an integer item and the second a pointer to the next node in the list as shown below. Remember, item is an integer here only for simplicity and could be any complex data type, this structure containing a member field that points to the same structure type called self-referential structure. A node may be represented in general form as follows: struct tag name and then the members of the structures and the data type and then the struct keyword tag name star next. The structure may contain more than one item with different data types. However, one of the item must be a pointer of the tag name. Okay, one of the item must be a pointer of the tag name. We haven't seen this syntax. These are all the different members with different data types, but this is the item that is a pointer to the pointer of the type tag name. Let us consider a simple example to illustrate the concept of linking. Suppose we define a structure as follows. This is the example of structure here. Struct linked list, one member, that is the age in the data type float. This is the linked list, that is the next node to be linked here. This is the pointer variable. Struct linked list star next. For simplicity, let us assume that the list contains two nodes, node 1 and node 2. There are of type struct linked list and are defined as follows: struct linked list node 1 comma node 2. This statement creates a space for two nodes, each containing two empty fields as shown below. So two nodes according to this structure definition. This is node 1 and node 2. It created two empty node. This is the node 1, this is the node 2. This is node 1 dot age, this is node 1 dot next. This is node 2 dot age and node 2 dot next. The next pointer of node 1 can be made a pointer to the node 2 by the statement node 1 dot next equal to ampersand node 2. This statement stores the address of the node 2 into the field node 1 dot next. You can see in this picture, XXX is the address of node 2. Girls, listen carefully. This is XXX is the address of the node 2 where the value of the variable node 2 dot age, okay, will be stored. Let us now see assign the values to the field age. Node 1 dot age equal to 35, node 2 dot age equal to 49. So here node 1 dot age is 35. This is the address of the node 2 where the value of variable node 2 dot age is stored. So there is a link between the first node to the second node. We may continue this process to create a linked list of any number of values. For example, node 2 dot next equal to ampersand node 3 means from the node 2 there is a link for node 3. Would add any link provided by node 3 has been declared as the variable of the struct linked list. Okay. No list go on forever. We have some n pointer. If you put a null pointer, that is the end of the list. So here in this example you can see every list must have an end. We must therefore indicate the end of the linked list. This is necessary for processing the list. C has a special pointer value called null that can be stored in the next field of the last node. In our two nodes list, the end of the list is marked as follows. Here the end of the list node 2 dot next equal to 0 means this is the last node in the list. So here this is the age of the first node, this is the address of the value node 2 dot age. There is a link between this node and node 2, but here the node 2 dot next is pointed as null pointer. So this is the last node. It does not point any node hereafter. Okay. So what are the advantages of the linked list are? A linked list is a dynamic data structure. Therefore, the primary advantage of linked list over array is the list can grow or shrink in size during the execution of the program. You can also see in this example also, if you want to increase the size of the list here, you just give the address of the next node here. So we just add any number of nodes. Like that we have also shrink the node by giving the null pointer at the end of the node in the next node. So this is also one of the advantages. The list can grow or shrink in size during the execution of a program. A linked list can be made just as long as required. Another advantage is that linked list does not waste memory space. It uses the memory that is just needed for a list at the point of time. So the third one is, and the most important advantage is that the linked list provides flexibility, is allowing the items to be rearranged efficiently. It is easier to insert or delete items by rearranging the links. Okay. So this is one of the important advantages in linked list. The major limitation of the linked list is that the access to any arbitrary item is little cumbersome and time consuming. Whenever we deal with a fixed length list, it would be better to use an array rather than the linked list. We must also note that a linked list will use more storage than array with the same number of items. This is because each item has an additional link field. So compared to array, there is some advantages and also some disadvantages in linked list also. So there are some types of linked list in C. There are different types of linked list. The one we discussed so far is known as linearly linked list. So linear singly linked list. The other linked list are circular linked list, two-way or doubly linked list, and circular doubly linked list. The circular linked list have no beginning and no end. The last item points back to the first item. The doubly linked list uses double set pointers, one point to the next item, the other point to the preceding item. This allows us to traverse the list in either direction. Circularly doubly linked list employs both forward pointer and backward pointer in circular. In this figure you can see the three types of linked list. This is the singly linked list. If you want to, this is the list, item 1, item 2 and item 3. If you want to insert an item in between the node item 1 and item 2, you just remove this pointer, remove this next pointer to the address of this x pointer. Okay. So and then you have to mark this x next node to the item 2. So you just add like this. And then if you want to delete an item, you just remove the next pointer from the next pointer node and it is marked to the item 3. This is the deletion of the node. So I will discuss you how the linked list created, how you add an item, how delete these item in my next video, girls. Thank you.